Hey everybody, my name is Graham. I'm the co-founder of GrowthBook. GrowthBook is one of the most popular open source feature flagging and A/B testing platforms. Like Jonathan, we also went through Y Combinator, although in winter of 22. Previously I was the head of engineering at a pretty large ed tech company. Today I'm going to give a talk about feature flagging at scale. You've heard a lot about this. I'm going to hopefully give you some slightly different nuanced takes on the problems that you can face when you're scaling up your feature flagging platform, and hopefully some solutions as well. So just to give you some idea of what we mean by feature flagging at scale. So this is borrowed from Ronnie Kohavi has this crawl, walk, run thing. So for feature flagging, companies often start with really no feature flags, but they might have some analytics. You then start to kind of add some flags on maybe some key features. Then you start running experimentation or running a lot of feature flags on quite a lot of your products. And then eventually you get to the point where you're doing ubiquitous experimentation, ubiquitous feature flagging, where literally every change you make is wrapped in a feature flag. And that's the default way of how you launch a new feature. And this is where your top companies are, like your Microsofts, LinkedIn, Netflix, Google. And to give you some idea of the sense of scale here, Google runs about 100,000 experiments a year, right? LinkedIn is at about 60,000. Right, so these are a much different set of problems that you're facing when you're running, just a couple features to running 100,000 features. And so this talk is going to cover two of the problems you're going to run into if you get into this phase. So one of them is dealing with old and stale flags, and the other one is around testing in this world. So jumping right into dealing with old feature flags. So everyone, as engineers, we also really love to do the fun parts of every project. So for me, that's designing, building, shipping. Sometimes launching is fun. And then measuring the impact of those experiments is also very cool. And then no one really wants to do any of the less fun parts, right? And for me, this is always bugs, dealing with documentation, and cleaning up code, right? That's probably pretty universal. And so this only gets worse when you start scaling up your use of feature flags. So I put together this your table here. So we have kind of a weird state here. So you have flags can exist in your coding platform, and in your feature flagging platform, and features can exist in your code, and they're not always synchronized with each other. So in the diagonals here, we have features that exist in both, and that's great. That's working as expected. And then in the, if it doesn't exist in both, also great, no problem there. Where it gets a little tricky is you have flags that exist in one or the other, but not both, right? And so how do you detect those states? So let's take a quick look at how some of the solutions how you can fix some of these states. So unused feature flags where it exists in the platform, but not in your code. And this might be on either side of the lifecycle. Maybe you haven't started building the feature yet, and maybe you've finished, you've decided on the feature, but you haven't removed it from your platform yet. So an IDE integration can help you add them. So we do have, most of the platforms will have IDE integrations that let you see the feature flags that you have available in your platform. And then you can use code references like Ryan showed, where you can see if the flag exists in your code base. And that's pretty much, that pretty much solves that problem, right? That's very feature complete. Stale flags, where the flag exists in your code but not on your platform, is a little bit of a trickier state, because you can only really address it when you stop the flag, right? So when you're changing the state or you're deleting that flag, that's a good point to kind of remove that flag from your code base. But if you don't do it, then it's kind of, now you have this flag and you're not really sure why it's there or if it's being used. And so there's a couple tools that you can use to help address this. There's static code analysis tools. The best one I know of is Uber open source their platform called Piranha. It does static code analysis and will open PRs directly against your code base to remove any unused flags. It does not use AI. Actually, they don't like using AI because of the hallucinations. But the team behind Uber's Piranha actually created their own company called Guitar, which if you want to pay for Piranha, that's a good way to do it. The other way you can address this is with ESLint customization. So you can basically have your code base scan the flags and then pull in a list of flags that are available And then if there's no match between them, it can highlight that as an error. You can also use like CI/CD actions to help do the same thing before you push code to production. Make sure the flag exists in your feature flagging platform. Cool. So just a quick look at the scale of the problem. Uber published some of the numbers around their use of Piranha. And they found that they created about 800 PRs per month at Uber's scale. They calculate this saves them about $16 million a year. I don't know how they do that math, but it's probably not quite that. But it's a lot. Yeah, very expensive engineers. Yeah. Great. So now we've solved the whole thing, right? So we're all set. Except it's not quite as clear as that, right? So there are some states of flags that are really somewhere in between, right? So we've already had some talks where people have found this, where you can have a flag that exists in your platform, but it's like incorrectly targeted or targeted to a group of people that may never actually exist, and then you're sort of in trouble. There's flags that can be in your code, but can actually be an unreachable, either that file's not included, or there's some condition where like they'll never actually get there. And these are sort of fundamentally uncertain. Good news is, in those 5 states we just created, 2 of them are actually already solved by the existing tools. I won't go into why, but you can kind of figure that out. But these 3 in the middle here are actually kind of hard. And they're very hard to figure out what's going on. We like to call these sort of Heisenberg flags, or like Schrodinger's flags, maybe. Some sort of like quasi-state here where you're not really sure where they exist, if they're actually alive or dead. So there's really no automatic solution for this. Event tracking is the best one that we have. I think the folks at Dynatrace talked about this earlier, where like if you log an exposure event of a flag, then if the flag hasn't been hit for a long time, maybe it's okay to delete. But you don't really know, right? Like maybe it's just not popular. So there's really uncertainty here. There's no real magic bullets, I'm sorry to say. There are some ways organizationally where you can address these issues, whereas feature flag cleanup, just make that part of your tech debt. Maybe you do bug triage weeks, have it clean up bug day, or clean up feature flag day. And then also have owners, like make sure that your flags or your projects have people that you can hold responsible for making sure you're not just creating a pile of flag debt. Okay, so how am I doing on time? Quickly then on feature flagging and testing. And so testing here, I don't mean A/B testing, I mean like unit testing, like acceptance testing. And so as engineers, we like to push code to production, and we like to know that what we push to production is actually going to work, right? And oftentimes if a feature is wrapped in a feature flag, it can be turned off, it can pass all the acceptance testing and be pushed to production, but how do you know that same code will work once that flag is turned on? And that's a pretty tricky problem. Some of the, so like when you have 100 flags, how do you figure that out? And so there are some ways to do this with automated testing tools like Selenium. You can make them aware of your your flags. Unit testing, you can make aware of your feature flag states. But usually they tend to be written manually. And so you have different combinations for each test, which is okay if you have a fairly simple testing scheme. So here, if we just had Boolean flags, we talked about this a little bit earlier, but if you just had 4 Boolean flags, you're creating 16 different tests to test all the combinations of those flags. If you have 10 Boolean flags, now you have 1024. And if you have 100 feature flags, you now have 1.2 times 10 to the 30th, which is a nonillion, which if every test took 1 second, would take 31 billion years to complete. So that's not really tenable. And it actually gets worse than that, because a lot of flag states are not Boolean. They're dynamically rendered, or they're remote configurations, and the actual states you're passing in might actually not even be known. And that just gets worse and worse. So what do you do? Well, you can kind of hit your head against this one. There's not really any great solutions here either. And most companies that do this kind of scale just don't bother, because it's too hard. And so what you do focus on is fixing things quickly when they break. So having good ability to roll back a feature when it rolls out. We're actually just launching a new feature on this next week. And the other part is you can really focus on testing just core groups of users and make sure their experience works correctly through your feature flag flow. This problem will actually get a lot worse with hyper-personalization. So you can imagine AI generating sites specifically for different users, and so that experience they get is entirely different, and it'll be basically impossible to test. So good there. Okay, so in conclusion, it's a problem to maintain feature flags at scales, but there are some pretty cool automated tools that make this possible. And then having good organizational practices will kind of catch those edge cases where the tools do not work. Automated testing is a problem because of combinatorial explosions, so just focus on catching the errors and trying to fix it on that side. And then finally, like, have good engineers, because there's no magic solutions here. So good news for engineers, AI hasn't fixed our job here yet, so cool. Oh, cool, thanks very much.
Any questions? No? Okay. I can have one. One question. Did you ever consider using like time-based solutions for feature flags to expire? Imagine saying, oh, you have 1 month to have this feature flag on, and as soon as this feature flag finishes, we just send a notification. Look, this experimentation is almost finishing. Do something about it. Could be one potential solution to, notify the...
Yeah, you can email people all they like. It's still annoying work that no one wants to do, so they're just going to ignore the email.
Yeah, that's a valid point.
Yeah.